Alright, today we're going to be talking about the forms of energy. You're going to need page 3 in your science packet today. We're talking about sound energy, heat energy, magnetic energy, electrical energy, and light energy. You'll be filling out this sheet as I go through the slides for today. Each one of these forms of energy has a definition, and you're just going to be filling in the blank, and then you're going to be coming up with 3 examples for each of these types of energy. So 3 examples of sound energy, 3 for heat, 3 for magnetic, 3 for electrical, and 3 for light. And I'll be going through that. However, I'm not going to be going back and forth between my paper copy of the packet, so you're going to have to either pause the video and jot it down, or just be writing while I'm going through. So, what exactly is energy? Maybe your parents or somebody who said, you're just full of energy, right? If you have a lot of energy, energy is really the ability to do work. That's just the basic definition of energy. And it's a property of matter. Matter is everything that's around us. All around us is matter because it just takes up space, right? It has mass and takes up space. I know that we talked about that earlier in the year. And energy being a property of matter means that there's energy all around us as well. Energy makes things happen. So when a light bulb lights up, that's energy. When a potato is baked in the oven, that's energy. When an orchestra plays beautiful music, that's energy. So energy is literally all around us when it comes to like light bulb, food, and even music, for example. And since it's all around us, it can take a variety of different forms, right? So it could be in sound, maybe it's heat, maybe it's magnetic, maybe it's electricity or electrical, or maybe it's just light. And so we're going to dive into each one of these. And like I said, on page 3 in your packet, you'll be filling in the definition and examples to go along with it. Let's first talk about sound energy. Sound is energy carried by sound waves. That's what you'll be filling in your packet. Made when an object vibrates. Maybe you've seen somebody play the guitar, maybe you play the guitar. When you go to play the guitar, you oftentimes use your fingers or a pick, and when you pluck the strings actually vibrate, and that's what actually gives it the sound. So this entire string, if I was to pluck it with my finger, it would move up and down, and that vibration would cause the sound. Here are some examples of sound energy that you can jot down. Headphones. As you plug in headphones into some sort of device, there's going to be sound energy that's coming through. Maybe just shouting in a room, right? That would be an example of sound energy. Or just speakers. Maybe you've sat next to a speaker and literally felt the sound vibrate the objects next to it, right? If it gets really, really loud. Or maybe you've heard of what's called a subwoofer. A subwoofer vibrates so much that I have a subwoofer in my house, and I watch a movie that's like getting really intense. The sound energy really makes a lot of vibration in my house. Especially if you've been to the movie theater, you probably noticed that as well. But then there's also heat energy. Heat energy is energy that is transferred or moves from one thing to another based on temperature and can change and cause changes in states of matter. So heat energy is obviously related to temperature, right? So when something gives off heat, that's like the warmth of it, right? And it can literally change the state of matter. In other words, you can go from like a solid to a liquid or a liquid to a gas by increasing or decreasing the temperature, right? When I think about, water, I can melt an ice cube by increasing the amount of heat energy, right, which will make all of the atoms and the particles move a little bit more, and that causes the melting of the ice cube into liquid water. So, what are some examples? Well, a thermometer is an example of heat energy that kind of records the amount of heat in the air, for example. Maybe a gas stove, right? You put a pot on a burner, you crank up the gas, the more gas that you are putting on the stove, the hotter the pot will be. Or maybe even an iron, right? And iron typically has to get really, really hot. That can iron out the wrinkles in a shirt, for example. But what about magnetic energy? Remember in the beginning of the year we did magnetism? Well, magnetic energy is the potential of matter to cause motion in its force field. In other words, we know that magnets can cause motion of different objects within the magnetic field, right? And so we know that magnets are detectors of iron, right? So irons basically will stick to magnets. But also, we know that magnets can attract or repel each other, right? So that causes some sort of motion when it attracts, they come together or pull together. And when they repel, they push away from each other. And that is some motion. So, some examples of magnetic energy in the real world. Did you know that roller coasters oftentimes use magnetic energy as it's moving across the steel? Or even a recycling center. I know I showed you a picture of something like this before, where they have a gigantic magnet that can literally lift up an entire car. Or even a refrigerator has magnetic energy as well. You can stick magnets right on a lot of refrigerator doors like this, for example. There's also electrical energy. Electrical energy is delivered by electric charge. So as we also talked about at the beginning of the year, when we did magnetism, we also talked about electricity, right? And electricity is based on the charge of atoms, right? So we have like protons and electrons, right? And that charge allows the atoms to flow on a path. Remember, some examples of electrical energy could be something like lightning, one of the most dangerous forms of electrical energy, power lines, or even just a simple outlet, right? These would all be forms of electrical energy. Then we have what's called light energy. Light is energy that moves in waves. So, if we were to take like at the atomic level or like look at underneath like a microscope of what light actually looks like, it's actually a bunch of waves that are going across your eyes, and it can actually like go the light energy can actually be like absorbed, it can be reflected. I'll talk more about that later today. But maybe you've even seen like a microwave, right? Microwave. The waves are created by light, actually. Or even a rainbow. Light energy and colors are even just forms of light. Or even an X-ray, right? That allows you to see inside of a body. All of these are examples of light energy. Now, energy, being that it's all around us, can actually be changed into another kind of energy. So you can actually turn like heat energy into electrical energy, or sound energy into another form of energy, right? So they can actually become different forms of energy. Let's take a look at some examples. If you take electrical energy from an outlet right here, and you plug it into a lamp, well, the electrical energy can be turned into light energy, right? Or if you take electrical energy from an outlet to charge your phone, and then all of a sudden your phone starts to ring, well, that would be sound energy, right? You're hearing the sound, and at one point it used to just be electrical energy that's flowing through the wire. Or let's say you have a stove, you're warming up some water in a tea kettle. Well, that would be heat energy, but as soon as the kettle starts to whistle, because it's getting really, really hot, then that would be sound energy, right? So you can turn those forms of energy into other forms. Now, also, forms of energy can be grouped based on how they interact with matter. Here's what I mean by that. Take a look at this fireplace here. We can say that this is light energy and heat energy at the same time. And that's because it's based on how it interacts with fire, right? I see the fire with the light that's coming off of it, but it's also I can feel the heat energy at the same time. Or, for example, here, if you had like solar panels that are on a roof of a house, well, they take the light energy from the sun, right? And they change that light energy into electrical energy, right? That can then be used for the house, or even heat energy for the house. You can actually turn that into heat for the home as well. Let's talk more about electrical energy. Electrical energy is a form of energy in motion. Here are some examples of electrical energy that we may or may not have already talked about today. Remember, electric currents from the beginning of the year is that constant flow of electric charge. There's current running through wires that are plugged into an outlet, and that is all based on the charge of those atoms. Hopefully this rings a bell to you. Remember when we were doing circuits at the beginning of the year? Well, a circuit, as you know, is just a system where the electric current can flow in a circle, right? So if you remember, the battery is like the source of the electricity. Then you might have a light bulb, which could be the receiver, and then the path is how it is being carried from the source to the receiver. And that would be electric energy that's flowing through these wires. And like I just said, the source would be the battery, the receiver could be like a light bulb or a motor or even like a bell, for example. You know, you have the path which is connecting wires, and then we could also have a switch, right? And the switch can open or close that circuit at any point in time. Again, that's all reviewed from the beginning of the year. So, as I said before, that electricity is flowing through the wires, and so that creates the electric circuit, and that is electric energy. But also, if you remember, as the electric energy is flowing, there's also a magnetic effect that is created, or like a magnetic field, like a little magnetic field that's created. Which is why we talked a little about electromagnets at the beginning of the year. And that causes motion, right? So that magnetic energy is also being created at the same time. So, in an electric circuit containing a battery, bulb, and the energy from the battery is transferred from the bulb, which is then transfer the energy to the surroundings, such as like light or sound or heat, right? So remember when I had the receivers plugged in and I would ask, how do I know that this receiver is working? And you guys would say stuff like, well, there's light or there's heat, right? Or maybe you heard the sound of the motor, right? Those would all be examples of how you know that the receiver is on. And it has everything to do with how the energy is being used. Alright, now let's talk a little bit more about light energy, another very common form of energy in the world. It's all around us all the time. So as I said before, light energy basically moves in waves, and sometimes we call that rays, right? So when the sun shines down on Earth, it's actually shooting out all these different sun rays, right? And when an object gets hit with some light energy, the light can actually change and be reflected, refracted, or absorbed. So let's talk about those three words. If it's reflected, right, the light basically bounces off of the surface. And so a really good example of that is when light is reflected off of water. Water does a really good job of reflecting the waves of light, and they just literally bounce right off the surface. Or light can also be refracted. So notice in this glass here you have a straw, but if you look down in the water, it almost looks like the straw was kind of like cut in half. Maybe you've seen this before in real life as well. Refracted basically means that it changes or bends the ray or the light energy. And so as it passes through, like this liquid right here, it kind of changes the direction of the light. That would be what refracted means. It causes the rays to bend. Or light can be actually absorbed or taken in by the object. So let's say that there's white light, which is a combination of all the colors. If it gets absorbed into the leaf, then what we see is green light. We don't see white. We don't see all these colors mixed together. Our eyes just see the green because the object has actually absorbed the light. Some objects are better at absorbing than others. So let's just review that. If light energy reflects, it bounces off. If it refracts, it bends. Or if it absorbs, it actually kind of takes in the light energy. All right, and that kind of concludes our energy notes. Hopefully you got information about sound energy, heat energy, magnetic energy, electrical energy, and light energy. Tomorrow you're actually going to be doing a project that kind of encompasses some of those forms of energy, and I think you're going to have a lot of fun with it.